Okay, Chapter 3, Day 3. What we're going to look at today is how do we divide radicals. We've simplified them, we've added them, subtract them, we've multiplied them. Now we're going to look at dividing them. And dividing them, there's a few different ways that you can look at the problem, so we're going to look at some different scenarios. So, sometimes you'll just divide the insides. So one way to divide dealing with radicals is just dealing with dividing the inside. So for example, if you ever see the square root of two numbers that can be divided, it's part of like simplifying, but you're still dealing with division here. You'll see in a second. Sometimes you might be better off just saying, hey, wait a minute. Why don't I take 40 divided by 2 and make that the square root of 20? Now I can simplify. Square root of 20 is 5 and 4, so square root of 4, square root of 5, which turns into 2 square root of 5. So that one I think we can definitely see that we can do. We're not actually dividing a radical by radical, but we're dealing with division within radicals. Okay? Sometimes it's easier to rewrite as a radical divided by a radical. Okay? So for example, if we look at square root of 49 over 16, boy, those are perfect squares. I'm just going to rewrite this as the square root of 49 over the square root of 16. I don't know what 49 divided by 16 is, but I know that I can take, just like when we multiply, we break them apart into two radicals, just like we did here. Took 20 and broke it apart. We can take a division sign problem and break it apart. Now I know the square root of 49 is 7, and the square root of 16 is 4, so my answer is 7 over 4. I can take a radical over a radical if I notice that these are dividing, they can divide into each other, and I could actually rewrite it the other way. I could say the square root of 45 over 15. 45 divided by 15, that goes in 3 times, so this is the same as square root of 3. So you might say, well, how do I know when to do this or that? You have to look at the numbers that they give you. And if we're talking about the square root of two things that are perfect squares, break them apart. Take the square root of them. If we're talking about a radical divided by a radical, and these are dividing into each other, write them as one radical and divide them into them. Okay? This one, a radical of two things that can be divided, divide them first and see what you get. All right? Sometimes, though, this goes a little bit farther, and you'll be asked to do something called rationalize the denominator. Now, again, rational numbers are like fractions or whole numbers that do not have square roots in them. So if you look at the problems that I'm giving for examples, they both have square roots in the bottom. I don't care what's on the top, but the bottom, the denominator has a square root. And so sometimes you're just going to be asked, hey, rationalize the denominator. Now, in this problem, again, I could have said rationalize the denominator, but what I wanted you to notice here, though, is in a case sometimes this number can divide in, so we just rewrite it. Usually it won't divide in, and we'll have to go through a different process. So here's the general rationalizing the denominator process, which is all part of dividing fractions. So, the first thing, and we're going to start out just with a basic square root problem. After Columbus weekend, we will get into more of a, what if that looks a little bit different. But, first step, you're going to multiply top and bottom, okay? Multiply top and bottom by what the radical on the bottom is. So, you're going to multiply the top and the bottom by what the radical on the bottom is. This radical on the bottom is the radical 10. So I'm going to multiply top and bottom by radical 10. Step 1 is done. Okay? And the next thing you do now is simplified top and bottom. You're just going to simplify this. So, well, when we multiply straight across. So 5 times the square root of 10 is 5 square root of 10. Square root of 10 times square root of 10. Well, here's the thing we talked about in the last video. Square root of 10 times square root of 10 is the square root of 100, because 10 times 10 is 100. But the square root of 100 is really 10. And if you remember what I said before, the square root of anything times the square root of anything, and as long as these anythings are itself, the answer is just itself. Whatever's inside the radical, whatever this is the answer, provided that these two are identical. If there's anything different, then no, that doesn't work. But the square root of anything times the square root of anything is the anything. All right? So note, the square root of anything, I mean, it can be smile face, that doesn't matter, times the square root of smile face. Okay? Square root of smile face times the square root of smile face is smile face. It doesn't matter what's in there, because taking the square root and then squaring it is like undoing and doing an operation. It's doing the operation, then doing the operation. So, one last step, reduce if possible. So step 3, reduce if possible. So let's take a look. Reduce if possible. Oh, 5 and 10. All right. So 5 goes into 5 once, 5 goes into 10 twice. This looks like it is the square root of 10 over 2. Square root of 10, I cannot break it down, so that's as simple as that gets. If we could break it down, we'd have to go even farther. Let's try this one. Okay. Let's follow the steps. Multiply top and bottom by what the radical on the bottom is. My radical on the bottom is radical 6, so I'm going to multiply top and bottom by radical 6. Radical 6 times radical 8 is radical 48. And radical 6 times radical 6 is just 6. Remember, square root of anything times the square root of anything is the anything. Okay, so we've done this. We simplified the top and bottom by multiplying these. And now reduce if possible. Ooh, square root of 48. That's one of my, has a perfect square factor. So let me bring it down here. Square root of 48 over 6. I can break that into 48. That's 16 and 3. Then I go radical 16, radical 3 over 6, which is 4 square root of 3 over 6. And I notice now that the 4 and 6 are reducible. 2 goes into 4 twice, 2 goes into 6 3 times. So this becomes 2 square root of 3 over 3. And that is dividing with radicals. Sometimes you'll be asked just to rationalize the denominator, and sometimes you'll ask to evaluate division within a radical, and if these numbers are perfect squares, we'll take the perfect square of each. If they're divisible, I'm going to divide. It makes my life a little bit easier. I could choose the same process of multiplying top and bottom by radical 15, and that'll work, but 15 times 45 is kind of a big number to deal with off the top of my head. So if I notice that one goes into the other, I can go ahead and set it up that way. And sometimes you might just have to divide within the radical, but this is how do we divide radicals and divide with radicals.